I'm Andrew Harris, and I'm an assistant professor in the Department of Mechanical and Aerospace Engineering at Carleton University, and I'm really grateful to be one of this year's Banting Discovery Award recipients. My lab really works at the interface between biology and materials science. What we're trying to do is understand what the material characteristics of cells and tissues are, and how these are important for both physiological function, and how changes to these characteristics can lead to disease. I'm actually a physicist by training, so I've always had an interest in understanding how things work and how things are built from the bottom up. And one of the most complex systems that we can think about are biological ones. So how do cells and tissues organize in different ways to create organs that have very specific functions? And I really think about this from a materials science perspective. So tissues have certain mechanical characteristics that allow them to both generate and sustain forces in their environment. And this is really important for their overall function. Some of the support from the Discovery Award will allow us to investigate how cells that produce platelets generate mechanical forces that allow them to shed platelets into the bloodstream. And this is really thinking about platelet production from a physical and mechanical kind of perspective. What we're hoping to do is gain new insights into how platelets are produced and maybe develop new ways that we can produce platelets ex vivo to reduce the dependence on donor source platelets for transfusions. So cell and tissue mechanical characteristics, as I've mentioned, are really important overall for their function. I think one of the most vivid examples of this is if you think about skin. We're all kind of familiar with injury to skin, and if you pull on skin, it's a remarkable tissue that can normally sustain a lot of mechanical force without rupture. Now, if you have diseases that actually affect some of the cellular level of function within skin tissue, you can get symptoms of tissue fragility. So skin that tears apart easily. And it's really that connection between protein function, cellular level function, and mechanics that we're interested in overall. The overall impact of my work that I'm hoping to accomplish, in particular with the Discovery Award funding, is to think about how we can engineer cell and tissue mechanical properties and maybe apply this to regenerative medicine. So I've mentioned things like platelet production being one of those, or maybe making tissues that have designed characteristics that could be used in skin grafts, for example. Throughout an academic career, there's a lot of challenges that one is going to face, and some of the best advice that I think that I received throughout my career is to, balance moving towards a goal with being able to change direction. So each week, it's good to think about making some amount of progress that is making you move towards a goal that you're trying to attain. And you can kind of keep track of that over time. And then maybe you need to pivot if things aren't going particularly well or things are taking too long. So there's really a good balance between having a particular direction, but also being able to change that direction if you need to. So that was some really great advice that I've had myself in the past. The broader goals that I'm trying to achieve are towards personalized medicine. So how can we engineer cells and tissues? I really think that we can use these as unique materials for particular functions. So that could be producing platelets. It could be, engineering the properties of those platelet producing cells so that they're more effective, or we produce platelets with designed characteristics for a particular function. And that's really the broader scope that I hope to move my career and research to in the long term. Another broad goal that I have is to give back to the students and some, great experience and mentorship, much like I had from my mentors during my career. I'm really grateful to have worked with some really great people who have steered my career in a great direction, and I hope that I can give that back to my students as they also transition through an academic career.